Hello everyone. So first of all, welcome to my channel, Cloud and Data with Kaushik. And this is the task 3. I forget to add the task 2. And this session is continuation of that previous session. Okay. I had some kind of network and keyboard issue. So that is the reason I'm not going to continue the session. So let's get started from the histogram that I have left over there, right? So So you can go and I just left some kind of notes over here, right? Histogram, how we can use this kind of thing. I just missed over there, right? So it provides a way. I can write here. Right? It provides a way to see how values are distributed across different ranges or bins. Bins means group, okay? And it provide the overview of the central tendency spread. Yes, that is different discussion. That is not there. Okay. That is the statistical discussion part. Great. And I just wanted to share why I'm going to use the histogram and shape of the data set. So understanding the data distribution, you can write understanding the data distribution. Please enter. And second point is that identify patterns. Identifying patterns to patterns in the data like right skewness, left skewness, right left skewness, okay, can be identified through a histogram. Can be identified through a through a his histogram. Okay, so that is identify our patterns, right? Okay, just hit enter. And also detecting the outliers. Detecting the outliers. So outliers, or we can say the data points that are significantly different from the majority, and it can be visually identified in histogram. Okay, so outliers we can identify, and we can also detecting the outliers with the help of histogram. Okay, that is the reason I am going to use the histogram. And also the last point, that's and also selecting appropriate analysis technique. So we can also write understanding the distribution of your data is crucial for, you can say, selecting appropriate statistical analysis technique. And different distribution, we can say, may require different statistical stage. Okay? Statistical stage. And also one point, that data pre-processing, I will just add and make it bold. And also one point that also important, data pre-processing. Just make it bold and then you can write. So in the data pre-processing, we can also say histogram can guide decisions. It can provide the decision about the data pre-processing steps, the techniques like binning or transformation. So it can use the grouping, the binds, the binding operation, or to improve the performance of certain algorithm, right? So I can write histogram can guide decision about data pre-processing steps like binning or transformation, or to improve the performance of certain algorithm. Okay? That is the reason we are going to use the histogram. So this is few points that I am adding. Why I am going to use the histogram. So understanding the data distribution part, identifying the hidden patterns of the data, like there is any skewness is there or not in the histogram. And we also use the detecting the outliers, like in a histogram, is there any positive outlier, negative outliers are present or not. And outliers maybe basically disturb the data, right? So outliers not good in such cases, right? And that is the reason we have to identify the outlier and we can write that outliers or the data points that are significantly different from the majority, and it can be visually identified because positive outliers is something. So it can taking the positive kinds of data sets, right? And negative outliers also be there. So that we have to going to understand. And also that selecting appropriate analysis technique. This can be different analytical techniques is there. We have to understand the distribution of your data is crucial for selecting appropriate statistical analysis part. And the different distribution, you can say it's required different statistical test, okay? And data pre-processing technique also. So it can help to improve the performance of certain algorithm, okay? So like binding or transformation steps. So these are the few points we have to consider while choosing the histogram. Let's take the code, how we can create the histogram. So just write plt dot histogram and or histogram hist plt dot hist. You can see hist it requires some beans. By default, these the parameters are taking, and it's a compute and plot a histogram, the hist plot. Everything is there. You just explore. This method uses numpy or histogram to bin the data. Bin means grouping. 5 to 10, 5 or 5 to 20, one bin. 21 to 28, one bin. This is a group, okay? Bin the data, X, and count the number of values in each bin, okay? And then draws the distribution. So that is the reason it grouping the data set is a bin format. It's called a bin, and it can be either as a your container, like a polygonal shape. So this is the bin, right? So bin, range, density, and weights are the parameters that are forwarded to numpy dot histogram, and then it will create it. If your data has already been binned or counted, use bar or stairs to plot the distribution. So you can see the notes, everything is there when I'm going to use or not. So other parameters, the indexable object optional, this object, indexable object, okay? You can provide also these things. So just write plt.hist and you have to provide the data set. Why I'm going to provide the data set? Because X, right? You have to add the data set. First, you have to add your data set. So iris.df, you can see already showing. You no need to add anything. And then we have to add sample length, and we are creating the beans. I already told. So 20, the beans is depends as per the data size. Okay. So just as of now, 800 something rows I'm going to see, right? How many rows that time I saw, and that is your, I think that 1 minute, I need this thing 150 rows. Okay. So 20 means I'm just going to add. You can see 150 over there. 150 means, right? 150. And 5 are the columns. So beans you can take 20 and colored sky blue you can take. Edge color you have to take edge color. That any color you can add is done. Okay. Once it's done, just write plt dot show and just write and just hit enter. So you can see they will create the data, right? So 8 beans they have created. Means 20 data set is there, right? So you can see the histogram is created, right? Now we have to add the title. First, my histogram is ready. Just write plt dot title, and you have to add the title histogram of people length. I just use one column staple length, okay? And all the demo I'm showing with this mostly the same staple length, okay? So you can take other columns also with there. And first identify the relation and then you have to put the column name. So you just write plt dot title histogram of staple length, okay? And once it's done, then you have to add plt and you have to provide the x label. X label means x axis title. So this is staple length, and also you can write plt dot y label, that is your frequency, okay? Just press Ctrl plus Enter and everything is ready. You can see this is the staple length is my x-axis and this is the chart that I have drawn. Okay, this is a histogram of the staple length part. This is the frequency 0, 2, 2 to 4, 4 to 6, 8. So as per the beans, that scale has been increased, right? It's not the proper bell curve. Something is different, but it's just overview you can get, right? The histogram. Next chart that I'm going to create, the bar plot. That's very easy. Just write here bar plot, and it display first time right display the mean of a numerical feature for each category. Okay, so it creates just bar chart, okay, and display the mean, mode, median, this mean, average, right, of the numerical feature for each category. It will display. So as of now, it's only one liner. One line I have added for the bar plot. Okay, so you have to create this thing in your code. Just a minute. So you have to create I'm just create average little length. Okay, and I have the iris df. Now you have to first group by species, to group by this column through the species. This is one column, right? And now first I have to see what the data will come. Iris dot group species, group by species, and then kettle. If I will hit it, um, just print this hello, or whatever any variable you can place. So the pandas group by, okay. And now what I'm going to do, I'm going to create the mean. Okay, this is the value of your after creating the group by and the Peter length I've taken after the group by and then I'm creating the mean and it will show this data on the Peter length on the basis of Peter length the species right. So Setosa, Versicolor, Versicolor, these three uh, this is the mean value is coming right. So I have to taking the mean and then I have to add the proper naming convention like average total length that is and then you have to do you have to copy this variable name and then you have to plot it. Kind means have to create the bar and color that should be your sky blue, any color you can take. Green, blue, okay. So one, two, three, that is the three colors I've taken. The three columns are there, right? And then you have to write plt dot show. No need to write because is not there. Just this and you have to pass first create these things and then you have to create the value. So this is just a normal bar plot. Okay? You can add the title, whatever is required, plt dot title. Okay, and you can write average return length by species plt dot x label and you can write species and plt dot y label. You can add the average return length. Okay, and your full page bar plot is ready. You can see this is my bar plot. Simple bar plot. Okay, you can do different things. You can create the color based on the value. This kind of things you can also do in the bar plot chart. Okay. Next part. I hope up to that is clear to all of you. Next chart is there are many charts I've created, right? And you can also infer other charts also be there, right? So I have created many chart distribution like scatter plot, pair plot, and your box plot, Violin plot, histogram. So you can explore more things. You can get the idea of creating the different kind of chart on the iris data set. And I think that this is the pair plot where you can get entire idea of this chart, right? Of the pair plot of your iris data set. Is there any questions or anything that you can ask? So I Just want to see that is there any problem or not that you can understood or not this concept. So please let me know. And I hope this you can learn something new, or I can see that uh, if you have any doubts, so please let me know. I have to wait 1 or 2 minutes, then we can close the session. Okay. The one chart that I need to I just missed out. Just I need to explore. Just 1 minute. Is the one chart that Heatmap? Just see the correlation data, right? Heatmap I also use. So it is usually used for visualize the correlation matrix of features in the dataset. Okay, that you can see. And heat map is very important. I have to write. Then first you have to compute. Everything is ready to us, right? To compute the correlation. Only one line code. Correlation. Only one line of code. You will get the correlation matrix. Like that core matrix is equal to your iris underscore df dot url4. You can get the correlation of your matrix. Okay. Now you have to create some kind of heat map. Create the heat map. Okay. So write SNS dot heat map. Okay. So instead of providing the data set of iris df, I just provide the correlation matrix. Okay. And anode is equal to true. And cmail, this is the pattern cmail. Okay. So this is the theme, full one. You can explore. I already shown in the matplotlib.org website is there, right? So you can explore. This video already be there before this video. So everything is discussed. So you can explore these things. So it will be helpful to you. Like plt.title, and you need to write correlation Heatmap, and you can write plot dot show. Okay. Just press Control Enter, and your correlation Heatmap is ready. Okay. So this is also be possible in the correlation map in the heat map. It's understand that correlation between the data, right? I hope you can understand this part. And one more chart that is also, you can say, rug plot. One is there, rug plot. We can use a rug plot, and it is used for visualize the distribution of data points along a single axis. Okay, that is the use case of rug plot. Let's take a look how it look like. So we have to create a rug plot. There are different use cases. Okay, so mostly I saw that pair plot, trees plot that is using. And there are many charts are creating, and bar plot. Histogram is mostly used. Violin plot, box plot, mainly pair plot also be there. So it can be there. And create a rug plot like SNS dot rug plot. You can provide. Yes, so this is, you can see this plot uh, mar marginal distribution of drawing trees along the x and y axis. This function is intended to complement other plots by showing the location of individual observation. Okay, individual observation. That is the reason I will use the single data point. Okay, and x we have to provide simple underscore length, and you have to provide the data. Here I have to provide iris underscore df, iris dataset you have to provide, and their height, that is 0.5. Okay, so plt dot title, you can use dark plot for triple length, and then you write plt dot show. Your plot will be ready. Single data point, this is the dark plot. And okay, as of now, one distribution that I'm going to see, this is the last, is the pair grid. So pair grid is used for creating a grid of those subplots. Just I'm right. Here, just take one text and write pair grid. Pair grid. Okay. Pair grid. So you can create a grid of subplots with pairwise relationships. Okay. So you have to write the code of pair grid, create a pair grid. You can write SNS dot pair grid, we have to provide the IDs underscore df this data set and just SPE spaces and it write plt dot show just one or two line of code. Okay. So PRO is relationship. Nothing is coming as of now, but also you can see whenever they added a distribution is there, right? Okay, and I hope this is the pair grid and but we have to do something. Something is missing. So we have to add one thing. So to map the scatter plot something over here and just write SNS dot to just a minute. So to write dot map diagram. Okay. And I have to write SNS dot I just plot everything in this subplot, okay? And then you have to write map dot map underscore of and write SNS dot scattered plot. This SNS dot scattered. Okay. Just please control enter. Yes. So my empty template is adding. So if you write this thing, just cut and write. So your empty template is ready on the pairwise relationship, but there is no data, right? And then you can add, you can map basically this diagram. SNS dot is plot and SNS dot scatter plot. And then you can write, you can hit, then you can get that your data like this plot, scatter plot that has been added with the help of pair grid. Good. And you can write plt dot title pair grid of IDs dataset. You can write pair grid of IDs data set. Just press Ctrl Enter and your data points are ready. Okay, so I hope most of the charts I have covered as per my knowledge. So if you have any charts, anything, so you can definitely let me know. So one chart we can club. Last one chart I can club. I can try. I can try to club. That is my violin plot with one plot. This we can add it. So what is the use case? It can combine a violin plot with individual data points using a swarm plot. Let's have a look on that. It can combine two plots. So just take a look. So we have to create a violin plot with swarm plot. Okay? So just write SNS dot violin plot, and you have to pass the x-axis, that is your axis, and y-axis, that you have to pass simple length, and your data points that you have to add your iris dataset, right? Iris underscore tf, and where it will be situated, that quartile format. Quartile. And like SNS dot swarm plot is there, swarm plot is there, and we can write x axis, this is y axis, we can add simple length, okay, and we can add data points, that is iris underscore df, and you have to pick the color of blue. Okay, and write plt dot show. Okay, so you can hit, and both charts are combined. This is a Violin plot and this is a swarm plot, right? And data range is quartile. Okay. Earlier we have created this chart na empty. This was empty Violin plot on the petal length, right? And here also we have created this thing with that swarm plot and Violin plot combination, right? So you can write that only one thing is pending, that is your title, PLT dot title, like Violin plot with swarm plot or simple length. Okay, and just hit again, and your plot will be adding, and with the heading also be there. So as of now, it is okay, and I have added the charts as per my understanding and as per my knowledge. So if you have any charts in your mind, so feel free to add in the comment box. So I also know that this part, so it can help me, and in this way we can grow and learn together. And please subscribe my channel, so it will provide me the confidence, and in this way we can also learn and grow together. And you also know this kind of materials and live coding, it takes so many effort, right? So I just need your contribution, so you can spread this video, and you can like this video, you can share this video, and you can subscribe that, because that can help you from me. So if you have any doubts, any questions, so please let me know in the comment box. So we can definitely address those concerns. And if you again, I'm telling, I have added the charts as per my knowledge. So if you have any things in your mind, so please let me know so we can also understand. And I will definitely add this code in my GitHub in the tasks to section, right? Because this is the enhancement of the tasks tool. I have not added the charts over there. Now I am going to add the charts. Okay. So it will be helpful for me, and I will add all the things in my GitHub repo, and I will share the link in the YouTube video. Okay. So in this way, thank you. Stay tuned with me, and thank you everyone for joining the session. Thanks.